Finally, we come to the last part about binomial expansion, binomial theorem, with another concept called general term. So general term here, we mean when we consider like expression a to the power p, a plus b x to the power n. So if you expand it in ascending order power of x, you have nc0, a to the power n, nc1, a to the power n minus 1, so you have bx. Next you have nc2, a to the power n minus 2, b squared x squared, nc3, a to the power n minus 3, b cubed, x cubed, so and so, until the last term ncn, so you have b to the power n, x to the power n. So this is what binomial theorem telling you. But now when we consider general term, it would be, can you see that when you're considering a different power of x, there is generally a formula. For example, when you're considering xc or x to the power 1, you will see that it's called nc1 and power n minus 1 and power 1 for the three terms. When you consider bx squared, next you have nc2 n minus 2 for power of a, b squared. Next you have x cubed, which means nc3 power n minus 3 for a, b cubed for b as a coefficient. So as a result, generally speaking, general term of this expansion would be NCR, or I would say in this way, so called coefficient of x to the power will be NCR, and then a to the power n minus r, and then b to the power r. This is called general term. And then for this general term, so it helps us particularly when you are finding a single term, or like a question in part D. Now we start from part A to see the idea. You are finding the fourth term in the descending power of x. So in the past, you will expand it term by term and check for the fourth term. But indeed, when you talk about fourth term in the descending power of x, it will be, so you have power 8, power 7, power 6, and power 5. So this is the fourth term. So that's why when you consider the fourth term, so it's talking about x to the power 5 here. According to the general term, that means it should be NCR, which n is your power 8, 5. Then you have, because you have want to have x to the power 5, so which means that you should have minus 3x to the power 5 over there. When you have a power 5, that means the power of the other term should be x minus 5, that means it's 3. Okay, let's wait. So it's 3 here, and the number should be at 2. So that's why you can quickly find the fourth term in the question instead of expanding the whole expression. So afterward, by calculator, you have 56 for xc5, 8 for the first one, minus 243 x to the power 5, so which is minus 108864 x to the power 5. So it's a bit harder, right? But then you can have practice yourselves to get familiar with it, or you can watch again a video to get the idea. Part B, I try to read the question with you as well, but the answer you try to work it out by yourselves. This time is part 3, so that's why let's write the term first. It's 7c something with 3x to the power certain something, 4 to the power certain something. And then now, because of x cubed, so you should have power 3 here, then you can write 3 here as well. So because it's power 3, so that's why it should be 7 minus 3, that means power 4 for the other one. So then you can work out the answer by yourselves. Some of you may ask, well, how about the number here? Should it be 4? 7c4, 3x to the power 3, 4 to the power 4? Yes, certainly. And the rationale behind it, because if you remember, NCR is symmetric, And so that's why NC3, NC4, they share the same value. So that's why I don't bother too much about how you pick the number here, because whatever you pick, 3 or 4, actually it gives you the same results. And then that's about A and B, about general term. And then next we come to C, how part C will be done by using general term. So it would be, okay, let's wait. One way would be, you know it's 6c something, 2x and 1 over 3x. If you want to have constant term, that means you want the x to be cancel each other. So because it's 6 here, so that's why you think of its power 3 and power 3 respectively. So that's why it's 3. So by calculator, you've got 160 over 27. That's alright, finish, right? But on the other hand, so if you use general term, then it will be done in this way, or written in this way. The general term this time will be NCR, and then 2x to the power r, and then 1 over 3x, which is it's not n, it should be 6. It should be 6 here, 6 minus r. So after simplifying it, you have 6r will be 2 to the power r, x to the power r, 1 over 3 is 6 minus r, and also 1 over x, 6 minus r. And now you put these two terms together. You have 6cr number, 2 to the power r number, 1 over 3, 6 minus r number. And for this one, maybe I missed a step, but the calculation will be here. It's r minus 6 minus r by index law. So that's why it's x to the power 2r minus 6. So what does it mean afterward? It means that, wow, that means finally it's 6cr 2 to the power r, or maybe I put it in fraction, is 2 to the power r over 3 to the power 6 minus r, x to the power 2r minus 6. Because it's constant term, that means 2r minus 6 should be a 0, which gives you r is 3. So that's why the constant term would be 63, because after you got r is 3 here, 2 to the power 3, 3 to the power 3, and then x to the power 0, which gives you 160 over 27. It's harder, right? But the point is, in a certain occasion, actually it's part D. So you can't use the first method to do the question, but you need to use the second one, using general term, to argue, to have a proper argument of the question. Now let's read the question together. I have no space. How about I put in the space as follow? So next we come to part D. Part D would be, you want to argue about whether there is a constant term or not. So that's why, except you expand it, total expand it, then you can see whether there is yes or no constant term. Or else you need to consider general term for the following argument. General term this time is power 7, so 7cr. You have x to the power r, 2 over x squared to the power 7 minus r. So by the same idea, you have to expand it. So you have x to the power r, 2 to the power 7 minus r, x to the power 14 minus 2r, and then, so what's that? 2 to the power 7 minus r as a constant, and then these two terms after simplification is x to the power, where is it? 3r minus 14. In order to have constant term, that means 3r minus 14 will be 0. But now you see that r is 14 over 3, so which is not what? Integer. Because you suppose r should be a certain power, so that integral power, so that you can have a constant term. But now, r itself, if it won't be an integer, so that means there is no constant term. Or in other words, that means the constant term is equal to 0. So this is the one of the very critical way how you use general term to present the answer.